Okay, so here we have paper, this is from the 5th of November paper, paper 1, so it's non-calculator, and I'm just going to go through question by question answers for this. Okay, so the first question, LCM of 108 and 120, so it's the lowest common multiple. Multiples is, it's always the, it's basically the first multiplication that 108 and 120 at the same time. We can start doing this but using like a Venn diagram. That's how I would always do these. If you wanted to, you could list them, so you could literally list the multiplications of 108 and 120 and then find the first one that they share. But this is much quicker. So here is my Venn diagram, and I'm going to find 108. I'm going to break it down in the product of its prime factors. So if we do this first, so it's 54 times 2 gets you 108. And then if we separate down 54, 27 and 2, just keep halving until you get to an odd number. And 27 is obviously an odd number. 3 times 9, circle another prime factor, 3 times 3. So now we have our product of prime factors for 108. It's 2 times 2. I always write it out like this. 3 times 3 times 3. And then if we just do 120 over here, so 60 times 2, 30 times 2, and we stop as soon as we get that prime factor. We stop, we don't need to go anywhere. 3 times 5. Okay, and so that's 120. I'll put that over here. So I'm running over a little bit of space here, but 2 times 2 times 2 times 3 times 5. So then we place this information, this one for 108 and this one for 120, into the Venn diagrams. So 108 and 120, they share a 2, so that when they share they can go in the middle, but you only put one in there. It's really important you don't put both in. And then there's another, they share another 2, and they share a 3. And then, okay, 120 has an extra 2 in it, and an extra 5, and 108 has 2 3s. Okay, so that's our Venn diagram done. Now, to find the lowest common multiple, you would then multiply everything together in all of this Venn diagram. Okay, if you want to find the highest common factor, that would be just the middle section, but this is actually the lowest common multiple. So then we just do we calculate what 3 times 3 times 2 times 2 times 3 times 2 times 5. Okay, and we actually know that this Venn diagram, the circle here, that actually equals 108. So we know that, so we can actually say, well, all of that here up to here is 108. And so we just times that by 2 times 5. Now 2 times 5 is 10. So you can kind of make some shortcuts here to make your calculations easier. And so, and obviously, if this is a non-calculator paper, so they're not going to give you really, really complex numbers to calculate right at the beginning of question 1. So that should be 1080, and then you just pop the answer in there. It's a little bit messy, I'm sure you can make that a little bit neater. But that would be the lowest common multiple of 108 and 120. Okay, question 2. There are 60 people in the choir, half the people in the choir are women. So 60 people in the choir, half the choir are women. The number of women in the choir is 3 times the number of men. The rest of the people in the choir are children, and then you have to give a ratio as n. Children to men, n to 1. Okay, so if 60 people in the choir total, half of them are women, so 30 are women, so 30 must be men and children. And then it says that there are 3 times the number of women in the choir is 3 times the number of men. So if women are 30, men must be, if you think of 30 being 3 times the value, it's going to be basically 30 divide 3. So 30 divide 3 equals 10, and that gives us how many men are in the choir. And then also, by deduction, so 60 minus the 30 are women, minus the 10 men, and so there are 20 children in the choir. So you've got 20 children. Okay, so 10 men, so the way around they want it actually, 20 children. So if you look at this here, it actually wants the children, 20, to the number of men as n to 1. Now, if 10 is 1, so what you do to get from 10 to get to 1, you would divide by 10. So you have to do the same on the other side for the children. So therefore, you end up with 2 to 1. There are double the amount of children than there are men. And it only wants the value of n here. So the value of n will be 2. Okay, so it's breaking that down, just making sure you're not, sometimes this can be overcomplicated, maybe read it through a couple of times, that sort of question. Okay, question 3, multiplying fractions. So to multiply fractions, you need them in improper. So to do that, you times the 4 by the 1 to get 4 and add it to the top. So that will be 7 quarters times, and then 1 times 3 is 3, and then add the 1. So that's 4 thirds. It's like saying that's 1 whole. 1 whole is 4 quarters, and then you've got another 3 on top. And that's the same as that one really. There's 4 thirds there, because 1 and 1/3 would be 4 thirds. Okay, and then timesing, you just times top by top and bottom by bottom. And then you're left with again an improper fraction. So you can divide it down. How many 12s go into 28? Well, 2 wholes. And then you're left with 4 twelfths. Well, you can reduce that down even more still. 4 over 12 can be converted to 1 over 3. So the answer is 2 and 1/3. If they give a question as a mixed fraction like this, it is vital that the answer is going in mixed fraction. You will get a mark probably if you did this, and maybe 2 because they might give you a mark for conversion and then a mark for this. I haven't studied the mark scheme on this particular question, but you may get 2 up to here, but you will not get 4 marks until you've converted it, simplified. For the 3 full marks, 3 marks, quite a lot of marks. So just make sure you do get all of those. All right, now this is it wants you to construct. Now construct means use your construction kit, and which is in this case would be a compass, because you're drawing a perpendicular line, but you want it to go through P as well. So it's not just anywhere. We're not just cutting it in half. We need it to go through P as well. So what we do, I don't have a compass tool on here, but what we do, we put our point on the P of our compass, and then we end up, what we want to do is open it up so that it goes past the line, and we do some arcs. Now you need to draw 2 arcs along this line, so that it's equal distance, and that kind of gives you equal distance between P and this line. Okay, so you end up doing a little swipe of your compass. It'd be roughly there and there. If you end up opening up too wide and it goes off the page, you need to just rejig it and make it smaller, because you need to have 2 lines on here. And once you've got those 2 lines, you then move your compass point to these points here, 1 and 2. So what you've got here, you've got 2 points which are equal distance from P, and you'll be bisecting this line here. You sort of pretend that this is the new line. So you end up drawing from this point here, you'll draw an arc which kind of goes like that, and then you'll keep it the same distance and then come to this side, and then you end up drawing another arc which looks a bit like that. Sorry, I haven't got a compass tool to show you exactly, but that's, you're moving from point P, your compass, to your new lines, and then you're drawing arcs like that, and then you can grab your ruler draw a ruler here, and you draw it basically through P and then through the things. You can see that I've obviously not done it accurately, but it should go through. I don't know if I'll be able to move this actually. It should go through the points here, here and here, and through P as well. So this obviously clearly doesn't, it's clearly not perpendicular. I'm just trying to move it straight, but it's not liking it. Hopefully you can kind of get what I'm saying anyway on this. It should be basically straight through there, and your arcs, it should also go through. It's not letting me move those things. There we go. You should end up with two arcs. So it kind of goes through, that's a little bit better. So the point, it goes through the point and then through P as well. And you would have drawn these arcs accurately from here. Okay, so sorry I haven't got the compass tool there on that, but hopefully you can understand and maybe watch a video on that separately. Okay, and you'll get full marks. You have to keep all the construction lines on there to get full marks. If you just draw a straight line down it, they won't give you any marks. All right, so question 5. ADB is a straight line. Okay, the size of DCB. So now we're looking at DCB is a ratio into the ratio of 2 to 1 of ACD. That one. So it's 2 to 1. So this is 2 thirds, and this one is 1/3. Think about this as, because it's ratio 2 to 1, so there are 3 parts altogether. So you're splitting the angle, this big angle, if you add the angles together, it will be 3 parts, and that takes up 2 of those parts, and that takes up 1. So 2/3 and 1/3. So that's the first thing to note on this. Now, it's quite straightforward if you think of A, B, C as a triangle. You know this is a straight line. You can see these are all straight lines. It tells you it is a triangle up here anyway. It shows you it's a triangle. So you should know that the angles of a triangle have to add up to 180. So we take away, we minus 75 and also minusing 51. And that will equal whatever this angle here is going to be. So let's do that. So 180, let's do it as a column. Let's do it like this. I'm going to minus 75 first. It's going to be 105. And then 105 minus 51. 5 taken to 1, 4. Obviously you have to carry that over. And that's 54. So the difference there is 54 degrees. And so this angle here, the last angle has to be 54, and we know it's in 3 parts. We divide it by 3. And I'll just show you a way to divide by 3. If you don't know what 54 divided by 3 is, you can just you can do a little bust up. So 3 is going to 5 once, and then there's 2 left over. So that's 24. 3 is going to 24 8 times, so that would be 18. So 1/3 is 18 degrees. So you can see that this angle here, the little one is going to be 18, and the big one is going to be double that, so 18 times 2, so which is going to be 36. Now what does it actually want? BDC, BDC. Oh, it actually wants this one here. So to get that one, you need to get this one here. So 2/3 is going to be 36. So then we write angle BCD equals 18 times 2, which is 36 degrees. And then this one is going to be the difference again, because again this is another triangle in here. So it'd be 180, take away 51, take away 36. So 180 minus 51, do that first. To 129, and then if we minus 36, it's up to you if you can do this in your head, that's fine. I'm just showing you that obviously it's a calculator paper. Sorry, it's a non-calculator paper, so you can always do all these checks. So 93, so that angle here must be 93 degrees. So angle BDC equals 180 minus 51 minus 36. It doesn't ask you to explain why. If it did ask you to explain why, you'd write angles in a triangle add up to 180, etc. But it actually doesn't do that. Okay, so hopefully you can see where I've got those from. But that's using, they've tested you on using ratio there and angles in a triangle. So it's kind of two things. There's 4 marks available, so quite a few marks actually. So, but there is, as you can see, there is quite a few kind of calculations that could potentially go wrong there. So that, you know, you do get marks for obviously workings. Make sure you do show all your workings on that, because you'll clearly for 4 marks you're going to get some working marks. Okay, question number 6. 4 red bricks have a mean weight of 5 kilometers. 5 blue bricks have a mean weight of 9. 1 has a weight of 6. Donna says the mean weight of the 10 bricks is less than 7 kgs. Okay, so first thing to do is find out the total weights of each colour. So to do that, for red, it's going to be 4 times 5. So all my red bricks weigh 20 kgs. All my blue bricks, there's 5 of them, and they have a mean of 9. Hopefully you can see why that is, because a mean, you add all the weights together and then divide them by how many they are. So that's why if you times it by the mean, you get back to the total value of the, if you would have just added them all up. Because you don't know, there could be obviously mixed weights in these. So obviously they might all be 9 kilograms, but they might not. They obviously average out. Oh. 1 times 6, obviously 6. Geez. All right. So we've got 3 colours, and if we just add them together, so all my bricks add up to 71 kilograms, and there are 4 bricks, 5 bricks, so there is 10 bricks in total. So all my 10 bricks equal 71 kgs. So if I then say 71, which is my total, I divide that by 10, I would get 7.1 kgs as my mean. And you can see what Donna's saying, the mean weight of the 10 bricks is less than 7 kgs. So then you'd have to get the statement mark on this. Donna is wrong. 7.1 is greater than 7. You can put your kgs there. Just saying something like that. So 7.1 is bigger than 7 because she's saying it's less than. You can use the greater than arrow to show that the 7.1 is bigger than that. So it's clearly not. She's clearly wrong. Is she correct? So make sure you get this statement mark saying that she's wrong and the reason why. And then you'll probably get a mark for doing this part. And then probably the 7.1 has a mark. Okay, so 3 marks available for that one. All right. Okay, question number 7. Now, this is where index rules come in. So it's only a 1 marker because all you really have to do when you're simplifying using indices, which have a bracket. So it's p to the power of 2 and then to the power of 5. So the rule is you multiply across. So it'd be p to the power of 10. Now the reason why is that p squared, you're actually timesing that 5 times, because that's what that means. You're doing the same thing 5 times. And if you think about the multiplication rule, is adding 2, 4, 6, 8, 10. Okay, so that's just an extension of that one. And that's why it's p to the value of 10. All right, now when there's numbers and indices, you can write it out. I prefer to write it like this. They always seem to write it as a division. And you can even put in the 1 there, just so you don't forget that that y is a power of 1, because it's there, has to be a 1. So then do it, when you're doing the numbers act like a division. So 12 divided 6, which is going to be 2. Now when you're dividing, you minus the indices, because this is basically x to the power 7 is x times itself 7 times, and then you're dividing it by x times itself 3 times. It's just cancelling down. So that therefore on the you will have on the top x to the power of 4, and then y to the power of 3 divide y to the power of 1. So you're just taking one of those away, 3 minus 1. So y to the power 2. Okay, so you get a mark for the 2, the 12 divided by 6, and then you get the full marks by getting that, the power 4 and power 2. The biggest mistake there would be that I think is people get wrong is this forgetting that you have to divide that 1 out. So they put y3 and forget that you have to clear that out. Okay. Question number 8. So the accurate scale drawing shows a position port P and a lighthouse L. I'm going to make it a bit smaller here. Okay, so, and it gives you a scale. 1 centimetre represents 4 kilometres. The only thing about scale on here I'm not sure of is if this is going to be the same as the scale on the paper. So, but I'll show you the method of it anyway, and you can kind of. So if you have done this paper, you may have different answers and it may be still correct. It's just that the scaling might be wrong on here. Okay, Alina sails a boat from Port P on a bearing of 70. So from Port P on a bearing of 70, when it's from here, always go from north. So let's get my line. Hang on. A second, just trying to figure out if that's 0, and then yeah, so on a thingy of 70. So let's just up here. 70 is about there. So that is on a bearing of 70. So when this angle here, oops, sorry. So where's my drawing? So on this angle here, that will be 70 degrees. Always measure from north, okay, and then that's on the bearing of. So anywhere along that line is on the bearing of 70. She sails for 1.5 hours at average speed of 12 kilometers per hour to Port Q. So this is where we need to see how far she goes. So she sails for 1.5 hours, average speed of 12 kilometers per hour. So if she says speed, remember speed, distance, time. To get the distance, you do speed times time. And it might be quite obvious really. She says for 1.5 hours, and this is her speed. So in an hour she does 12. In an hour and a half she's going to do another half of that. So that's going to be 18 kilometers. So 1.5 basically times 12 equals 18 kilometers. So 18 kilometers along here. See if I can grab a so as if 1 centimetre represents 4 kilometres and I'm going 18, so what I would want to do is do divide 4 to get how far, how many centimetres I want. So 18 divided by 4, we're dividing anything by 4. You halve it and halve it again, so that's 9, and then it gets you 4.5, so 4.5 centimetres. Then you want to basically grab the ruler. Ooh. I think this should measure my line. Oh, it's not giving me a measure. Sorry, I thought I had a ruler on here. Okay, so is this going to give me a ruler? No, that's not either. Okay, so what you want to do, sorry I can't do this really, but you need to measure up here 4.5 centimetres up to here. So let's say it's about here. So this has to measure 4.5, okay, centimetres. And then that gives you where port Q is. So port Q. And then find the distance in kilometres of port Q from the lighthouse L. So then you get a ruler and measure. I'll do a line here. Then you measure from port L how far that is. So then you would literally measure that. Okay, I can't do that on here. It won't let me for whatever reason. I'm sure. I don't know where that's gone. Measure that from there, and that tells you how far it is from L. And then it says the bearing of port. So now we want the bearing of port Q from lighthouse L. Now the bearing, this is the bearing going along here, for that line I've just drawn to Q. So we actually want the angle here, because you always measure from north and you always go in the clockwise direction. So you'd get your protractor and you'd measure, it gave me that. You'd measure from there, see what that is. So it's actually from north is 21. So from here it's 21. So if you think about it, if you measure that as 21, this here is 360 minus 21. So 360 minus 21, 339. Okay, so it's quite a bit. I mean, I don't know if that's exactly right. Obviously, I'm just kind of showing you really how the method. It's very difficult to do scale stuff on screen, and obviously without a protractor as well, it's not quite as easy. Without a ruler, sorry, it's not quite as easy either. But hopefully you understand where that sort of all come from. You have some answers down here. So distance of QL, whatever that is there, I think it works out about and then if you find out how long it is, let's say it's 6 centimetres, you'd then need to work out how much that in kilometres. So 6 centimetres, so then you just times that by 4, because each centimetre is 4 kilometres, so 24 kilometres. Again, I've had to kind of guess those, so then you'd write that in there. And then bearing, we did that 339. Again, could be wrong on there because everything is based on these measurements and I can't do that. But I hope you understand some of the language. It's really important to understand the language on bearings questions, and always measure from north clockwise. Okay, so moving on from that one. A car travels with 18 minutes an average speed of 72 kilometers per hour. How far will the car travel in those 18 minutes? So another speed, distance, time. They generally use quite a few of these. So we've got the speed, and we've got the time, so we need the distance, basically how far, that's distance, so you're just going to times one with the other. Now the problem with this one is that 18 minutes isn't in hours, but this is in kilometres per hour, so you need to convert this to, I would normally do this, because we know we haven't got a calculator, so I can't use a calculator. This is really 18 out of 60 times 72. So that's the actual formula for it. Probably the easiest thing to do, obviously you've got more than one option, but the easiest thing to do is reduce this down as a fraction. So 9 over 30, you can see that's exactly the same thing. And then you can divide that by 3 out of 10. So it's 3/10 times 72. So that you can do 3 times 72 divided by 10. That might be the easiest way to do it. So 3 times 72, 2 times 3, 6, 3 times 7, 21, 260. And then divide that by 10, so 21.6 kilometres. Okay, so that's how far, the distance they'll travel in that time. Okay, and it kind of looks about right, doesn't it? It's about a third of the way. 72, that seems about right. Okay, David says 72 kilometres per hour is faster than 20 metres per second. So what should we do first? So 20 metres per second is this, and 72 kilometres per hour. So how many we can kind of do this either way around really. So 72 kilometres, so how many metres would you go? Well, you times it by times it by 1,000 to get how many metres per hour. Now metres per hour, but we want it in seconds, so then you'd hours and seconds is 60 times 60, so you'd have to divide this by 60 times 60. 60 times 60, if you think of 6 times 6 is 36, and then add the zeros, so 72,000 divided by 36, and then 3,600. So then what is that? So then we can cancel down some of these zeros, and we're left with 720 divide 36. I'm just trying to make this as an easy equation as possible, and then we can halve it, because you've got 18, and halving that is 360. Let's maybe be able to see some connections, links here. These numbers are going in a little bit nicer, aren't they? Because 336 divided by 18 is 2, so therefore 360 divided by 18 has to be 20. So that is actually exactly the same. So I've just worked out 72 kilometres per hour in metres per second, and it works out as 20, which is the same. They are the same. You could have done it the other way around. So I could have converted 20 metres per second in kilometres per hour, and you would have got this to this. So it's just saying it's exactly the same thing. Okay. Okay, so question 10, cumulative frequency table on how many minutes it takes to complete a puzzle. Okay, they're giving you a grid, they're giving you the table. Now, this actually tells you the cumulative already. Okay, sometimes they give you the frequency. It already has worked out the cumulative, so it's just plotting really. Now, the biggest thing to remember with anything with cumulative frequency is that you always plot the last number. So for example, 20 to 40 is 5, So 20 to 40, you would mark 40 as 5, and then 60, 25, and then 80, 35, 138. Be a little careful on this one, and then 40 for 120. And then you go from the start to your nice smooth curve from the start, the 20, all the way up, and then it normally tapers off like that. So you normally get this steepness at the beginning and then tapers off. It's a little bit wobbly, but hopefully you can see what I've done there. So the main thing is really to plot the last number of the range. Okay, so that's that plotted. 2 marks, 1 mark will be for the nice smooth curve, the other mark will be for the positioning, the plotting. Okay, use your graph to find the estimate for the interquartile range. It's always an estimate because you've got a range. Okay, 20 to 40 is 5, you know. These are, it gives you a range, it's always going to be an estimate. So the interquartile range, first of all, we'll find the lower quartile. Now quartiles, you're basically splitting the cumulative into 4. It's 4 quarters. So you'd get a line, and the first quarter, 40 divided by 4. Oh, God. Sorry. 40 divide 4 is 10. So our first quarter is 10. Our second quarter would be 20, so that's sort of halfway. And our third quarter, so the lower quartile, would be on 10. The median would be on 20. And the upper quartile would be on 30, because that's 3 quarters. So then you do 10, if you wanted to, 3 times 10 equals 30. They do normally give you some nice numbers. Okay, so let's draw our lines. Lower quartile, you draw a line up to the graph, and then another line, picking up the wrong thing here, another line from here, it's not liking my lines, all the way up, let's move that out of the way, all the way up to there. So you should get here, and so your lower quartile would be about 43, and your upper quartile, you go along here, let's draw the line and then I'm going to move it. It's been a bit strange this actually, upper quartile, and then you move the line This is much easier to do on paper. Okay, and then insert another line, and if you look going down, it's about here. Going up to there. Okay, so we're looking at about 66 there. So your lower quartile equals 43. They'll give you a little bit. They will give you a little bit of leeway on the amounts. About 66. Okay, so if that's your lower quartile and upper quartile minutes, then the interquartile range with the upper quartile minus the lower quartile. So 66 minus 43 equals 23. So 23 is our interquartile range. Okay, hopefully you can see that. And it's basically the range between this and this. If you did a box plot, it's the box, it's the bigger box. Okay, so 23 minutes is the interquartile range. All right, and then it says one of the 40 people is chosen at random. Use your graph to find an estimate for the probability that person took between 50 and 90 minutes. So 50 and 90 minutes. If you go to 50 minutes, it's along here, see between the 40 and the 60. So 50, we'll look here to here, and then another line here. It's not liking me today at all. Okay, roughly about there. So again, they will always give you a little bit of range. So it's about 15. So that works up about 15. 15 there. So 50 is about 15 cumulatively, and 90 minutes. Again, get your line. 90 minutes goes up to that, and then from there all the way along, and that's about 35, 37. So it's about 37. So between here and here, 37 and 15 is your range of how many people, that's frequency. So 37 and 15. So between these numbers, so 37 minus 15. So if you sort of put all these people in a line, the 15th person will be roughly around 50 minutes, and the 37th person will be roughly 90 minutes. So it's just the range of how many are within that. So 37 minus 15. 37 minus 15 will be 15. Oh, mine's gone blank, 22. If you wanted to, you could just do if your mind goes blank like mine just did for a second, yeah, you just do a minusing, just do a column. That's 2 marks for that. You'll find 1 mark will be for the 15 and 37 and maybe drawing on there, and the last mark will be for minusing it and find that 22. So it's quite a lot of marks for that one. 6 marks in total. Remember, each mark is roughly about how many minutes you should take on them. There's a bit of a rough idea, but that's roughly how it works out. Alright, so the next one is a probability question. There are P counters in a bag, 12 of the counts are yellow. Shafiq takes at random 30 counts out of the bag, 5 of these counts are yellow, work out the estimate. Okay, now this is called something. This is actually called capture recapture. So what you're doing, you're estimating. Capture recapture. What you're doing, you're estimating using, and they use it a lot in populations. It's kind of, they quite often use fish and rabbits and stuff. This is basically if 12 of the counts are yellow, and then you're taking a certain amount out of them, you're taking 30 out and 5 of them are yellow. It's like a proportion of the population. So and think of it as again as in fractions. So 5 out of 30 were yellow that he took out. So this must equal, and we know that 12 out of the total population are yellow. So the only unknown we don't know is this full population, and we can rearrange this. And by doing some rearranging, so 5 over 30 equals 12 over the full population. There's a few ways you can do this, cross multiplying. So over here 30 times 12 and 5 times p. So you can do it like that. So 5 times p equals 30 times 12. Now if you think about 30 times 12, 3 times 12 is 36. So 30 times 12 must be 360. Now if 5p equals 360, to find p you do a division, so 360 divide 5, and if you want you can do this, use bus dot method to do this. So 5's into 360, 7, 5 times 7 is 35, so you get 1 left over. 5 into 10 is 72. So we've got an estimate of a population of 72. Okay, so that's capture, recapture. If you want to have some more practice of those ones, that's what that's called. Okay, so here is a 1 marker, this question 12, but it's quite a, you have to use the correct wording, etc. You have to see why this doesn't work. So this is a rearranging equation. Spencer's method to make Q the subject of the formula is here. What mistake has he made? Okay, so what I would do is actually do the actual thing. So T equals Q over 2 plus 5. Well, because this Q divided by 2 is nothing to do with this plus 5, you kind of have to get rid of that plus 5 first. So you'd be minusing 5, so T minus 5 equals Q over 2, and then you'll be timesing this by 2, so 2 times T minus 5 equals Q. Okay, and you can so you can see straight away what's happened. He's actually times by 2 first, and you can't really do that. And if you do timesing by 2, you'd have to times the 5 by 2 as well. So because this part here is only the division by 2, this hasn't been divided by 2. So this timesing by 2, so you have to put maybe something along the lines of Spencer should have minused the 5 first, or you could have put or multiply everything, because you can times everything by 2, and that will clear that division, but you have to times this 5 should have been 10 by 2, and if you'd done that it still would have worked. Okay, so you just have to say one of those things really. All right, next question. It's question 13. Write 5 over x plus 1 plus 2 over 3x as a single fraction. So what you have to do is get the the bottom, the denominators the same, and to do that you can just times both together basically, because then you know if you times this whole fraction by 3x and you times the other fraction by x plus 1 top by top, and then you know that they're going to have the same denominator. Okay, so let's do that. So first fraction times by 3x, so you end up with 5 times 3x should be 15x over, and then it'll be 3x times x plus 1. And doing that, you're timesing both top and bottom by 3x. That basically means you're timesing it by 1, so you're not changing the value of the fraction. And then you change this fraction times this fraction by x plus 1, so you end up with 2 times x plus 1. Then obviously in the denominator you should have exactly the same. Okay, then all the denominators are the same, and I'm going to expand the top as well to get 2x plus 2. You end up with 15x plus 2x plus 2 all over, so that's a plus, all over 3x x plus 1, and then simplify that further, should be 17x plus 2, and the bottom, we could expand the bottom out, 3x squared plus 3x, or just keep it as it is. I just wanted to do that to see if I could see anything that cancelled out, but no, that's the final answer, 17x plus 2 all over x squared plus 3x. Okay, there's 2 marks for that question. You get a mark for setting them out like this, timesing them both by the denominators, and then you'll get your final mark from the actual answer. Okay, next one. Factorise x plus y squared plus 3x plus y. Now this one is only 1 mark available, so this might, I saw a lot of students doing this with trying to expand it out and expanding it all out first. But actually, if you look at these terms separately, this term here has a factor x plus y, and so does this one. Okay, so what we can do is almost take that out of both, divide both terms by x plus y. So you end up with x plus y, and then x plus y, plus, and then dividing this by x by y, you just get 3. So you end up with plus 3. So what you've done, you've divided both this part with x plus y, and then also this part with x plus y. So this part is just 3, and this is x plus y, because obviously x plus y squared is that, basically times that. Okay, so hopefully you can see it's more spotting that one, because only 1 mark. If you see it's only 1 mark and you're not sure what to do, I would probably leave it and come back, because it's not going to be expand it and do all sorts of things just for 1 mark. Don't waste lots of time on 1 markers, but obviously have a go or come back to it, because you might have more chance coming back and look at it with fresh eyes sometimes. Alright, question 14. Here is a right angle triangle, and it tells you both side lengths in algebraic terms, x minus 2 and x plus 4. Okay, so the area of the triangle is 27.5 centimetres squared. Now, area of a triangle, to find the area of a triangle, you do base times the height, and then you would divide that all by 2. And we know if we did that, we would get 27.5. Now you cannot do this with trial and error. When I marked many papers, a lot of students did trial and error, just put different values in x, and it worked actually, and they got the answer. But you will not get full marks. You have to do this algebraically. So here is, I've set out the equation. You'll get a mark for doing that. And let me just see how many is available here. 4 marks. Okay, so you will get the mark for that. And then if you think about, if you're doing this, divide 2 equals that. You times both sides by 2. You end up with x plus 4. And that will equal 55 centimetres. And then we can expand this out, and what we'll end up with is a quadratic. Quite often you get this because you're timesing x by x, so you get that quadratic. And just to simplify that, x squared plus 2x minus 8 equals 55. So what you want to do, you want to minus the 55 from both sides. So you end up with x squared plus 2x. Minus 8 minus 55 is minus 63 equals 0. So now, as you can see, I can try and factorise this and solve it. So, excuse me, we want two numbers which multiply to get minus 63 and add to get 2. So let's have a think about this. 63, you've got, so to get 63, you can do, divide by 3. Okay, so 3 times 21. Now, can you add them in any way to get 2? Now, obviously one of these would have to be minus, but either way, that's not going to get you 2, positive 2. 63 goes into 9 times 7. Now we can see now 9 and 7 have a difference of 2. So if we make the 9 positive and the 7 the negative, you would add them to get positive 2. So those are your two numbers inside the factorising So x plus 9, x minus 7. And then remember, we want to make this 0. It's the whole idea. So to make the 0, x has to be the opposite of this, because each bracket we want to equal 0. So x equals either 7 or x is going to equal minus 9. Now, this is really important with this because you've got two answers. You think, well, how do I have two answers? How can x be two answers? Well, actually they can't, because x cannot be a negative. If I replace this with minus 9, I'd end up with minus 11. And you just can't have a length which is a minus value. Okay, so you have to look at it and think, well, it can't be the 9, must be 7. So if x is 7, 7 minus 2, so that's going to be 5. And then 7 plus 4, 11. And you can see 5 times 11 equals 55. Excuse me. And then obviously divide that by 2, you get your 27.5. I'm just doing a little test on that. That's my test. Or check. So 5 times 11, that's your x value. And actually the question, because I was doing all that, and actually the question asks, you must show your workings, work out the length of the shortest side of the triangle. Now the shortest side is this one, 5 versus 11. So therefore, the length of your shortest side is 5. Okay, so these, even if it doesn't look like a quadratic, it could end up a quadratic. Okay, so really practice quadratics in every format. Okay, express 0.418 as a fraction. The 1/8 is recurring. You've got these little dots here, means they're recurring. You must show your workings. Alright, so there's methods in recurring decimals. So this has got a non-recurring element, and what you have to do, the first thing you do, is to times it so that the recurring decimal, the non-recurring decimal is past the decimal. So I'd need to times it by 10, and so I like to say that x is 0.418. 10x is going to be 4.18. And I'm going to just do this to show you that the 4 doesn't recur, but the 18 does, the 1/8 does. And now what I want to do is make it so that the decimal is all the way past one whole set of recurring decimals. In this case, it's 2 recurring, so you have to do another 2. So that's actually going to be timesing it by 1,000. I'm actually going to put it on top of my 10. Equals 418.1818. Obviously that goes on forever. Now what you've got here is now a calculation taking one away from the other. You can see they line up. So I've had to go over 10 to get rid of that 4. You need to get rid of that 4 first of all. Then take a whole section of the recurring element across the decimal. And then you're going to be taking one away from the other. So 1,000 take away 10 is 990x. And then minusing across here, 418 minus 4 equals 414. Then obviously these all cancel out. So 0, 0, 0. So you don't need them. That's the whole idea, really. So x must equal 414 divide 990, and then simplify that. So I can halve it, so you end up with 207 divide, where are we, 450. And then I can't obviously see anything else on here. That's going to go to I don't think it's divisible by 3. Can't see any more. They don't always worry too much about the simplifying, but that looks like, I think, as simplified as it can go. Okay, so that's the answer for that one. So it's really important that you You get that? And if you get these wrong, if you get these out, if you do 100 by mistake, you'll notice because it'll be out of sync. So you just then start again. Okay, rationalise the denominator. That basically means get rid of this third on the bottom. Okay, and it was just a one third on the bottom like that. You can times it by basically the same third over itself, which effectively, similar to when you're doing algebraic fractions, it's just timesing it by 1. So it doesn't change the value, but what it does do, it moves things. So root 11 times root 11 is just 11 because it's root 121, which is the same as 11. You're undoing the square really. So square root, you're squaring a square root, which just gets rid of it. And then 22 times root 11 would be just 22 root 11. And then you can see 22 and 11 obviously go into each other. So 22 divided 11 is 2. So it ends up with just 2 root. Okay, so the next question, show that this can be written as this. Now this is a bit longer, you've got a little bit more going on at the bottom. It is a third, but it's also got a number, so you have to times it by the conjugate pair of this. Now what I mean by that, if we keep the 3 the same at the top, and then 2 root 3 minus 1, you're going to multiply it by 2 root 3 plus 1. It's just going to be the conjugate pair, the opposite symbol over itself. It has to be the same thing up top and bottom, so it makes 1. And if I times root 3 by this, so root 3 times 2 times root 3 is the same as 2 times 3. So root 3 times root 3 is root 9, which is actually 3. So 2 times 3 is 6. I've just done that times that, and then root 3 times 1 plus root 3. And then at the bottom, you've got 2 root 3 times 2 root 3. Now, 2 times 2 is 4. Root 3 times root 3 is 3. So really what you're doing is 4 times 3. So that would be 12. 2 root 3 times 1 is just 2 root 3. And then 2 root 3 times minus 1 is minus 2 root 3. So you actually end up cancelling this times this times this one, 2 root 3 times 1, and 2 root 3 times minus 1 cancels out. You always get that, that's the whole point, because then you get rid of the third on there as well. So we can kind of ignore those two. You can write them out if you want to, and you'll end up with plus 2 root 3 minus 2 root 3 to show the workings if you want to, or you can just cancel them straight away. And then minus 1, the only one we haven't done is minus 1 times 1, so minus 1. I'm going to rewrite that much neater. Obviously these two cancel down, 12 minus 1 is 11. Then you can't actually do anything other than that. 6 and 11 don't go, or nothing's there that we can do, but it is in this format where a and b are integers. So a and b, they're integers, and they've already told you really there's going to be a root 3 at the top. Okay, so that's rationalising denominator, and slightly with a conjugate pair, where it's 2 terms at the bottom. Okay, similar cylindrical containers. Now for this, people might think, oh, I need the formula for a cylinder. You don't actually, because this is all about the scale factors. So the surface area of container A and the surface area of container B is 4 to 9. Now, so that gives you the area scale factor for 9. Now, if I want to find the linear scale factor, I would have to square root it. The linear scale factor is going to be 2 to 3, because when you have a line and then you times it, we're just talking about linear, like the height difference, for example, that's times 2, but then the area times it by 2 squared, because you're timesing it basically 2-dimensionally. And then, but this is actually asking you about the volume. So we've got the area scale factor, they've given that to you. You have to go back down to the linear scale factor, well it's 2 to 3. And then to find the volume scale factor, you would cube it. So that means that for every 8 of one, there's 27 of the other voluminously. Okay, and then what is actually asking, so Tyler fills container A with water, she then pours all the water into container B. Tyler repeats and stops when container B is full. Okay, so basically how many 8s can we get into 27? Okay, so 1 8 would be, or we could just do 27 divide 8 equals, well how many 8s go into 27? It'd be 3, and then you'll be left over 3. It doesn't really matter because you actually need, you want it to be full of water, so you actually have to do it 4 times because otherwise it would not be full. So it doesn't matter how much more than 3 is, it would still have to be 4 to get the full full of water. Okay, so that's scale factors, and you see anything to do with area, it's always a square root down to the linear and then cubing it to get volume. Sometimes they give you the linear, so then you have to square it, etc. It's just understanding that really when you multiply the line, that just doubles it in length, but if you did the same with an area, you're timesing it by 2 squared. Okay, question number 18. The function f is given by 2x cubed minus 4. Show that the inverse function, because this minus 1 means inverse function, is 50 equals 3. So there's 2 ways you can do this. Inverse just means it's putting it in the other way. So they're saying if you put 50 in inversely, you get 3 out. And you could actually say, well, if you put this in the correct way round, you would get this out. So you could do it either way round. So that's probably what I would do, because inverse is just literally doing the same thing backwards. So if the function is, I'll just show you what I mean with that actually, rather than, so if you're going in, if you think of x, what's happening to x, so first of all you would cube x, then you would times it by 2, then you would take away 4. Now inversely, if you did this, if you put in x in inversely, you're going to have x, you're going to minus 4, then you're going to divide by 2, and then you're going to cube root it, because that's all the opposite. It's going literally backwards through this. Oh, sorry, add 4. Add 4, divide 2, and then cube root. Okay, so if I did that with 50 plus 4, 54, divide 2, 27, then I cube rooted that, that would give me 3. So if I did 50, and then I'd write that down, 50 plus 4, divide 2, cube root would equal 3. Or what you could do is put the 3 in the right way round. So if I put it around the right way round, because this is what's coming out, I would do 3 cubed, which is 27, times 2, 54, minus 4, I'd get 50. And that's this one. So it's kind of doing the other way round. So you could do it either way. Okay, so maybe practice some inverse functions like that. That's how I would think about it. But if I've been given the inverse in, and therefore the output, I'd probably just put it in the right way round to get 50 out. Okay, function is actually given by, so you've got 2 functions now. Find the values of x which hgx equals here. So find the values of x for which hgx equals 3x squared plus x minus 1. So what you need to do, hg is kind of putting g into x. So what you would do is putting g into x means that this here is going to be put into the x of h. So the h function is x squared. So if I put in the g into it, what will we do? Every time there's an x, we put x plus 2. So it'd be x plus 2 squared. Okay, so that's basically just inputting in, substituting in the value, whatever is in g, into the function of h. Okay, and then if I expand this out, remember when you're squaring something, you're squaring the whole thing, not just part of it. X squared plus, which is 4x plus 4. Okay. Then what it says is find the value of x for which this equals this. So I've got this now. Now I want to make it so that it equals 3x squared. So 3x squared plus x minus 1 equals this function. And then we rearrange it. So let's minus the x squared over here. And then I'm going to be minusing 4x over here as well. So minus 3x. Got minus 1, and you're going to, oops, that's a positive 4. You're going to minus 4, so minus 5. Alright, and we're left with another quadratic. Okay, so find the values of x. So values, it actually gives you a bit of a clue there's going to be more than one. And this is a harder quadratic because you've got the 2x here. And my method is just to split it. There's lots of ways of doing these harder quadratics. Slight trial and error. If you think minus 5, there's only 2 ways to get minus 5, and that's plus 5 minus 1, minus 5 plus 1. And then you could rearrange it so you think about what it could be in the middle. I like to do, I like to do the x, I like to sort of separate the information out and do it like this. So if I draw an x here, I do 2 times minus 5, which gives me minus 10. And then I put the minus 3 here. Now what I need now, the two numbers which multiply to get minus 10 and add to get 3. So multiply to get minus 10 would be 5 and 2. Okay, now which one has to be minus? Well, the 5 has to be minus because we want minus 3. And if we put both of those over 2, this actually, these side parts give us the numbers. Well, they nearly do. If you rearrange, 2 over 2 can be simplified down to 1 over 1. So I hope you can see that there, 1 over 1. So we then use that. They literally go into our brackets. I'll show you how. So this 1 over 1 basically means 1x, so just x, plus 1. And this here, the 2 on the underneath becomes 2x. And the minus 5 is the number. So you can see 1 times minus 5 is going to get you that minus 5. 2x times x is going to get you your 2x squared. And if you times out the other bit, so 2x times 1 is 2 x's, minus 5 times x, so there would be 2 minus 5, so minus 3x. So your two values of x, again remember we always want the opposite sign, minus 1, 5 over 2. Okay, so you've got two answers on that. It does allude to that when it says find the values of x, so it does allude to the fact there might be more than one value of x. Okay, so hopefully you followed that one. There's some composite functions going on here, remembering that the second is always going into the first, so it's g into h. And then when it says find the values for which this equals that, well, you have to do this first, make it equal that, and then solve through, you're left with that quadratic. 4 marks available. Not overly generous, but hopefully even if you start putting the composite function together, you'll get a couple of marks just on that part. Okay, so here's an indice question, number 19. And if you look at the numbers, the 9, the 27 and the 3 can all be done in the base number 3. So if we just convert that first of all, so 9 as a base number 3 would just be 3 squared to the power of minus a half equals, and 27 would be base 3, but then that's cubed, which is the same as 27 to the power of a quarter, divide 3 x plus 1. Okay, so now it's all in base 3. We can times out the indices. So 2 times minus 1, so it's 3 to the power of minus, 2 times minus a half, 3 to the power of minus 1 equals, and then 3 to the power of a quarter, 3 to the power of 3/4 divided by, and then this is just 3x plus 1 for now. Okay, now the thing to remember with indices, when you divide indices, you actually take them away. So if we just change this around to show that we just look at the indices, and they behave in a very different way. Obviously the division is a minus, 3/4 minus x plus 1. Okay, so in this case we can rearrange the formula. So minus 1, I'm going to move over here actually, so it's plus 1, so it's 1 3/4 equals, and if we move the minus x, this will be minus x and minus 1, if we expand that out, so minus x, if we add an x to both sides, we'd end up with x, sorry, I'll do it over here, x over here, and then this is minus 1, we'll keep that here, and then therefore x equals, so 1 3/4 minus 1 is just going to be 3/4, so that's the value for x. So the first step is to get it into the base number, the same base. Then once you've done that, you can times them out to get them in indice format. And then you're just going to take the indices as they are separate. You can kind of think of these as slightly separate. And because you can do that, they're all in our base 3. And then a division of indices is always a minus, so you're minusing one from the other. Okay, and it's just rearranging that, being a bit careful with that. Alright, x equals 3/4. That's question number 19. Okay, so question number 20 is a transforming graphs question. So the graph is giving you the graph. On the grid, draw the graph of the equation, and it wants you to transform this function x plus 1 and then minus 3. Now, the thing to remember here is that when you are, anything inside a bracket affects the x-axis move. So when I say the x-axis move, if you think of it as a vector, the x-axis move will be where it's going, and it's always the opposite of what it looks like. So x plus 1, so instead of plus 1 it's going to be minus 1. So we're going to move the x, all the x values, minus 1, we're going to move it back this way left at minus 1, and then this one, which affects the y values, that actually stays as it is. Anything outside the bracket affects the y values, anything inside a bracket is the x value. Okay, so now to transform this one, so what we would do to the graph, sorry, we're going to move it down 1, down 3 across 1, or across 1, I should go left minus 1 and then minus 3. So this point on this graph goes down 3, would be here. So then we can just draw our graph. We know the point is there. We're still going to draw the shape exactly how it should be, so then it would be exactly the same. Just, so it's 3 across, so it goes up like that, and then it goes across 2. It's exactly the same shape, exact same function, but it's moved left minus 1 and minus 3. Okay, so that's your first A. Point A, which is minus 2, 1. lies on the graph, y equals that. When the graph is transformed to the graph, this equation, then where does it map to? Where does it map to if we transform it? Now this is a reflection. Now anything inside the bracket, remember, affects x values only. So what that means is the y values will be the same. So it's going to move, it's actually going to be across, it's a reflection in the, to reflect in the y-axis. So what will happen, this y-axis down here, this will reflect over here. So this point, minus 2, 1, now becomes 2, 1. Okay, so the y, so the coordinate there is 2, 1. So what's happened, as you can see, the x value has changed, but the y has stayed the same. Okay, so that's what that means inside here. It's a bit confusing, it's reflection on the y, but it does only affect 2 and then 1. Yeah, 2 then 1. Okay, so I hope that's quite clear. Transforming graphs. Really key things to remember is anything inside the bracket affects x values. Anything outside the bracket affects y values. And that's really, if you've just forgotten everything, if you can try and have a go at just remembering that bit. And that's transforming graphs. I'm on question 20. Okay. So question 21. You have a quadratic and it wants you to sketch the graph of this, showing the coordinates of turning point, exact coordinates of any intercept with the coordinate axis. Okay, if you want the turning point, we are going to need to complete the square. So we may as well start, that could be our first point really to do that. And it is a difficult one too, because we need to take, because it's bigger than 1, it's x squared, so you need to take the 2 out first. If we do that, we're left with x squared minus 4x minus 5 over 2. Okay, and then what we do from here is we kind of have to keep the 2 in, but then we complete the square in the middle, just how you'd normally complete the square. So this would be minus 2x, minus 2, so get the 2 outside, and do like a big square bit, and then inside x, you'll do half the b value squared, and then remember you minus the square of this as well, and then minus 5 over 2, and then all take that all out. Then just to tidy it up a little bit, this bit here, remember this bit up to x minus 2 squared minus 4 is kind of up x squared minus 4x really, it's just kind of undone it. So completing the square format. And to tidy this up, minus 4 minus 5 over 2 will be minus 6.5, 6.5. So 2 x minus 2 squared, oops, minus 6.5, leave like that. And then what you need to do is multiply this 2 out, this just this part, leave this as it is, because then you will end up having squared. And if you times 2 by minus 6.5, you end up with minus 13. Okay, now this is now in completed the square format. So your turning point shows itself within these coordinates. So this is the x value from the bracket. So, and it's the opposite way around. So what makes this 0? Well, x would be, so the coordinate, the turning point coordinate is going to be 2. And we keep the y the same, on the outside the same thing. So we know the turning point is going to be 2 and minus 13. Okay, so I'm just going to write a little note about that. Turning. Okay, and we also know, before I move on to solving and the x-axis intercept, also know the y-intercept is minus 5. So that's actually already given you 2 points, and definitely would be 2 marks. So if I just come further down and start sketching, I know that my graph, and it's a positive x squared, so it has to be positive, that's going to be at -5, and my turning point is at 2 minus 13, so 2 along, minus 13, let's say it's down here. Doesn't have to be to scale particularly, as long as you've got the coordinates written. Okay, so we expect it to come up here, and we kind of know it's going to turn here and go up here, but you still need these points where they turn here and here. Sorry, where they cut the axis. Okay, so let's move on to that. Because we're in this format, we can then use this format to solve. And so I'll just rewrite it out here. And to solve this function, when it goes through the x-axis, y is equal to 0, and that's all that means. So now you're solving it for y when it's 0, so what is x? Okay, so take the 13 over to the other side, so it's 13 there, 2x minus 2 squared, oops, so then you'd do, you'd divide all by 2, 13 divided by 2 is 6.5, 6.5, and then you'd square root it, square root of 6.5. You think about square rooting of 6.5 as well, just take a little side note again on this. So the square root of 6.5 is kind of, it's going to be greater than, because the next square number down is 4, so the square root of 4 is 2, it's going to be greater than 2, and less than, so 4 and then 9, so less than, so it's going to be basically between 2 and 3. Okay, so just give you an idea roughly the number. Quite like to think about that, especially when you don't know when you're putting it on the axis. And obviously, sorry, that's plus and minus. As soon as we take that over, we must do that plus and minus. And then it's going to be 2 plus or minus the root of 6.5, 2.5-ish, we say. So it's going to be bigger than 2, so that's why this is over here. So 2 minus is bigger than 2, isn't it? So that's going to be negative. So here it's just going to be 2 minus root 6.5. And over here it's going to be 2 plus square root of 6.5. Like I said, it doesn't have to be to scale. This certainly isn't, but it is. The important part is the working out and the 1, 2, 3, 4 points. This one, even if you've forgotten everything, generally speaking, you'd get a mark for just sketching a positive shape through the -5, even if you didn't, if you managed to get these all wrong and forgot what you were doing. I think generally speaking, you'd get that mark. So it's worth having a go, even if you've forgotten you're completing the square, harder kind of questions. Okay, so that's that question. Question number 22 is the last on the paper. A, B, C, D are 4 points on a circle. And it's okay, so question 22, A, B, C, D, 4 points on a circle. A, B, C, D. A, C and D, B are straight lines, so it's just saying that that's straight and that's straight. Going from, it's quite a few things you can pick up just looking at this. We actually are more interested in what we're doing here. So congruency is proving something is exactly the same size, same angles, everything. Okay, and we're looking at DCB and ABC. So it's the two kind of slim, if you like, triangles across the circle. Okay, so first thing we can note is this AD is an equilateral. So when you say equilateral, they're all equal sides. You can even note when there's equilateral, they have to be 60 degrees here. Okay. Also means that this one here will be equal, be 60. And this is also another equilateral triangle because the distance has to be the same there. So this also has to be an equilateral. 60 and 60. Okay, so that's all about the equal sides. Now let's look at the other angles we can see from the circle theorem. Then we've got the bow theorem going on here. So you've got these, the point here, CDB and CAB are going to equal the same because of the angles in the same segment are equal. It's that and that one. And the same for the other way around. This is bow, it's the bow theorem, but we've got angles in the same segment are equal. So that means this angle, let's call it angle X, is the same as X, and Y is going to equal Y over here. Okay, so that's our kind of noting on there. So let's have a look at actually proving that. There's 4 marks available for this. This is all about proofs, so it'll be all in the words, making sure you're saying the correct words in the right place. So first of all, you can say, if you look at the angles that are the same, so it's Y and Y, that is the top of the triangles that we're trying to prove a congruence. So first of all, that already proves CDB equals CAB, and that's because angles the same segment are equal. So that proves one of the angles are the same. You can also say that if you look further down here, it's the same over here. These two, DCB, if you look at DCB, that's the other angle of this, the bottom, so DCB. So if you put DCB equals 60 plus angle and angle Y, and then but also ABC 60 again plus angle Y. So that's proving that those two, another angle is the same. And the third angle in the triangle you can actually see are both going to be 60 because they fall inside the equilateral triangle under here. So that will be angle ACB equals DBC, and then you can write in there because equilateral triangle. So that proves at the moment AAA almost, because you've got angle there, angle down here, and then the other third angle. Actually proving 2 angles is fine because the other angle will always be the difference between the two, because they always have to add up to 180. Now we need to write something to prove a side, because otherwise you're just proving similarity. Now with this, if you think of the triangles, this line at the bottom here, this is what I would do is this line BC is a shared side. So BC equals shared, therefore proves angle, side angle, and congruency. As long as you've got one side length. I mean, you could say that these from the points to C and are also the same, but it doesn't matter as long as you've got one side down there written down. Okay, so that should get you 4 marks on that question. It's generally 2 marks for the kind of notation and everything, and then 2 for the talking about angles from the same segment are equal, and the fact that it's an equilateral triangle. You sometimes get marks for marking on here, but it really depends. I would try and do both. Okay, so that is the end of the paper. That's the last question. Excuse some of my writing on some of these, it's a little bit crazy. So hopefully you've learned something from some of that, and any comments, any things you think are wrong or different, please feel free to comment down below. Okay, thanks.